Hello to everyone watching this recording. My name is Pushan Lau from Group 2. Our topic is prefabricated piles and board piers in commercial construction. First of all, let me begin by introducing these two types of deep foundation methods. Board piers, are also called drilled piers, are constructed on site. A drilling rig is used to bore a shaft into the ground to remove the soil. Once the shaft is completed, a steel reinforcement cage is inserted to strengthen the structure, and then concrete is poured to form the pier. On the other hand, prefabricated piles are manufactured in the factory and then transported to the construction site. They can be made from timber, steel, or concrete. However, due to the transportation limitations, their size is restricted. Board piers, on the other hand, can be constructed much larger. After delivery to the site, prefabricated piles are lifted and driven into the ground by a hammer. This installation method generates significantly noise and vibration compared to board piers. Generally, prefabricated piles offer faster construction speeds. Factory production allows for better quality control and reduces on-site labor time. The method is suitable for projects in remote areas or where fast installation is required. For example, large warehouse developments like Bernie's and Harvey Norman often use prefabricated piles. However, board piers are more suitable for high-rise building or large-scale commercial projects because they can be built larger and deeper. They provide a higher load capacity. They are also ideal for use in urban or crowded or populated areas because their drilling process produces less noise compared to the driving method used for prefabricated piles. A great example is the Langham Hotel on the Gold Coast. As a high-rise building constructed near the ocean, it required deep foundations due to the high groundwater level and large structural loads. The project used a combination of deep footing methods, including board piers, which were ideal for these conditions. Now let's look at the most common types of board piers. First one is straight shaft board piers. They are the most basic type in the board pier family. As I mentioned earlier, the construction process involves site preparation, drilling with the shaft rigs, inserting the steel reinforcement cage, and then pour the concrete. The method is suitable for most of the stable soil conditions with minimal groundwater. As for the belled board piers, they are an alternative type of board pier that use under-reaming tools to enlarge the bottom of the shaft. By increasing the base area, they can carry greater loads and resist uplift forces, which may reduce the number of piers required compared to using just straight shaft board piers. However, the soil must be cohesive enough to hold the shape, otherwise the enlarged section may collapse during construction. There are more advanced types of board piers using different soil conditions. My team member Jeremy will introduce them. Please enjoy.
Hello, my name is Shenjie Qiu. In this slide, I will show you the construction progress of two types of ball piers, socket ball piers and case ball piers. Let's start with the socket ball piers shown on the left slide. These are used when the surface soil is soft, but there's solid rock deeper down. Now let's see the step 1. Step 1 is to drill through the soil until we reach the rock. Step 2 is to keep drilling into the rock. This creates a socket about 0.5 to 3 meters deep. This helps the pile hold tight in the ground. Step 3 is cleaning the hole to remove loose material. This makes sure the concrete will bond properly. In step 4, we lower the steel reinforcement cage into the hole. Step 5 is pouring the concrete in one go. And finally, step 6 is letting the concrete set and exposing the top of pile of structure above. Now let's see the right side. We have case bore pairs. These are used when the soil is very soft, loose, or has water in it, where the hole might collapse during drilling. Now let's see the step 1. Step 1 is drilling a borehole into the soil. Step 2 is installing a steel casing to support the walls. Then in step 3, we clean inside the casing. After that, we will find the next steps 4, 5, 6 are similar to socket piles. At the bottom of the slide, you can see diagrams showing how each method works. The left diagram shows the progress of socket piers. The right one shows how casing is installed and later removed. So to sum up, both systems follow a similar progress, but the main difference is at the start. One type drills deeper into rock, and the other uses casing to protect the hole in weak soil. Now let's look at the second slide, which shows the key difference between the socket and case bore piers. First, the purpose. Socket bore piers are used when strong support is needed. They go deep into rock to carry heavy loads. Case bore piers are used to stop the hole from collapsing in soft or wet soils. They help keep the hole stable. Second, we will find the drilling depths. Socket piers are drilled into rock, usually 0.5 to 3 meters deep. Case piers don't always go that far. They're drilled into design depths, and then casing is added. Third, we'll find the key procedure. For socket piers, the main step is drilling a socket into the rock. But for case bore piers, the key step is installing the steel casing. Fourth, the equipment used. Socket piers need strong tools like core barrels and rock augers. Case piers always using casing pipes, shimmy pipes, and rotary augers. They are better for soft ground. Fifth, let's check the soil stability. Socket piers work well when the surface is weak, but there are strong rock below. Case piers are better for loose of water-foil soils. And finally, the cost and difficulty. Socket piers are more expensive and need more skill. They are used for big structures like bridges. But case piers are cheaper and easier to build, so they are common in normal build projects. So, in conclusion, I think we choose the correct type depending on the ground, the structure, and the budget. That's my understanding of the socket bore piers and case bore piers. Thank you.
Hi everyone, my name is Hongwei Cao from Group 2. In this part of the presentation, I will be presenting a summary of two key types of prefabricated piles: precast concrete piles and steel pipe piles. Let's begin with precast concrete piles. As you can see, for conditions used in, they are particularly good for soft and expensive soils, and require open site access for large equipment. This makes them suitable for projects such as mid and high-rise commercial structures and various types of infrastructure. The primary equipment needed includes a piling rig with a leader to guide the pile, and cranes for handling. Looking at cost, they are generally more expensive than shallow footings due to high upfront manufacturing costs, but they can be cost-effective on large projects because of rapid installation. This leads us to their advantages. They are reinforced for durability, allow for high installation speed, and are very effective for supporting heavy loads. However, they also have significant limitations. The installation causes much noise and vibration. Specizing the BIOS panels can be a challenge, and it's difficult to check the quality once they are in the ground. Next, let's look at steel pipe piles. For conditions used in, they are very flexible. They can be used in many types of soil and are very effective in difficult ground, even with things like large rocks. This makes them great for city sites with limited space. Because of this, their projects are often foundations for very tall buildings and big projects like bridges and ports that have very heavy loads. The equipment often used include special vibratory hammers, and welding tools are very important for joining the pile sections together right at the site. Looking at cost, the steel material itself costs more than concrete, but because these piles were so strong, you might need fewer of them, so the final project cost can be still good. The best advantage is that they can carry very heavy loads. Also, they are very flexible because you can easily join them together to make them any length you need. They can also push through very hard ground. Finally, for limitations, their main weakness is that they can be damaged by rust, so they need special coatings for protection. And, as we said, the material itself costs more. So, to summarize, the choice between these two prefabricated piles comes down to a clear set of the speed and controlled quality of cast concrete versus the flexibility, strength, and adaptability of steel pipe piles. This analysis of driven prefabricated systems provides a clear baseline for our main topic.
Hello everyone, my name is Hao Huang. I'm from Group 2. In this part, I'm going to talk about two common types of prefabricated piles, which are steel edge piles and timber piles. Let's start with the steel edge piles. Edge piles are one of the most common prefabricated piles nowadays, especially in those massive, large constructions that require deep foundation to transfer the loads down through the footings, like high-rise buildings, bridges, stadiums. Steel edge piles is similar to steel pipe piles in their function, but differ from pipe piles in their cross-section shape. Edge piles are dimensionally square, is as wide as they are deep, and have the same thickness in the flange and the web. The H-shaped design provides a better weight distribution over a wider area. Individual piles has been tested to withstand loads of 1,000 tons, which is really remarkable. This kind of robust design allows you to withstand immense loads, which makes them very ideal for supporting heavy structures like skyscrapers, bridge, industrial facilities, etc. Also, one of the advantage is that it can be readily spliced together on site to achieve the required length for the deep foundation, which is really flexible. Also, H-piles are more efficient in dense soil that offer pile resistance at the tip for point bearing capacity. H-pile system is very stable and reliable because it has been tested over 100 years in construction. But there are also some limitations to steel H piles. It's relatively expensive compared to other pile types. Um, it costs more in material. Also, it can generate a significant noise when driving the pile down. It's penetrating the soil, which might not be ideal to construct in CBD area or high density residence area. Also, due to the nature of steel, it's vulnerable to rust in corrosive environment, but it can be improved by thickening the thickness of flange and the web. Timber piles are one of the oldest prefabricated pile types used in Australian construction, particularly before modern materials like reinforced concrete and steel became widespread. Historical construction like Wash Bay in Sydney applied this specific timber called turpentine, which can last in the water for more than 100 years. In nowadays Australia, timber piles are not commonly used in modern commercial buildings due to their limitations, such as low load bearing capacity, termite damage, and marine barrier. Also, it has shorter lifespan compared to reinforced concrete and steel. However, they are still occasionally used in lightweight or low-rise structures, particularly in soft or swampy ground condition. Timber piles are installed by hammer rig. You might also see them in marine application like jetties or bulwarks. There are also some advantages using timber piles. They are renewable resources. They are good to the environment, and it's relatively easy to transport and install. It has lower material costs and installation costs. While timber piles are no longer the first choice for modern commercial projects in Australia, but it still has significant historical importance in Australia construction.
Hello everyone, my name is Yichun Fang, and today I'm going to introduce two different cases of board piers which being used in real commercial construction site. The first one is obviously the Perth Children's Hospital, which we can call it PCH. It is being under construction in Western Australia. So as we can see, it's a 10-story hospital, which includes an emergency, a surgical and intensive care provision of more than 298 beds. So what kind of board pier and why this kind of board pier is being used? The Perth Children's Hospital used straight shaft board micropiers, hand-augered and torque drilled through the existing strip footings, grouted and dwelled to needle beams. The main reason why this kind of board piers is being used is because the low vibration and underlay under a delicate 1930s masonry building. A simple straight shafts were used since the load was not high and the quality of the founding soil was competent in shallow depth. And there are four more detailed explanation for this kind of board piers. This picture is taken in 2012, which the hospital is under construction. The first one is obviously the high load capacity. Capacity to carry the high structure, which is 10-story hospital, carry the weight of the multiple story facility. The second one is precision. The depth and the place may be counter-checked per column line. The third reason is minimum disturbance. Minimum disturbance to the ground next to live hospital locations. The last one is the sustainability. This is suitable to deep layered profile of soil typically found in Perth. Because this hospital is being constructed in Perth, so that's a very necessary detail. Let's move on to the second one, which is Western Hospital, another hospital, but being constructed in Sydney. Different to the hospital with the Perth one, it's a 14-story hospital. It is much more larger. This contains 2 emergency departments and 1,500 rooms. As we can see, the foundation of the main tower is socketed board piers. There are the dimensions. And we can also see this is the picture that a completed strand of case-secant board pier wall forming a permanent basement retention while this bulk excavation is on the way. The second picture is we can see the Kelly Bar piling rig is installing a 1,000mm rock socketed board pier here. And there is a steel cage waiting to be lowered. A lattice-boomed crawler crane assists with the cage handling beside the live hospital facade. So, what about this one? What kind of board piers is being used for the Sydney hospital and why it's being used? This one is using a case board, or we can call it a second piers, to create a perimeter basement wall installed using temporary steel casing to manage the underground water and provide excavation support. The main reason why this rock-socketed shaft's being used is it can apply the high axile load at low levels of settlement. Cased and second piers provide a low vibration retaining wall option that is adjacent to. Here are a little bit more explanation, a further deeper explanation of this board piers. The first one is ultra-low vibration, so it will not disturb the near adult and children hospital. The second one we can see it is the strong rock socket strength, which is 1,000mm shaft, 3 meters to the chain and can support 10 to 12 millinewton per column, which upholds the 14-story tower, gives them a very strong support. Next one, the second wall used the dual purpose, a temporary supporting wall in excavation and a permanent waterproof basement. The fourth one, we can see the underground water control. It is very necessary and important for control the underground water. Temporary casing plus termite pool maintains the socket clean and more than 6 meters through soft alluvium. The last one is the noise control. The quiet drilling did not interrupt the operations of the hospital, which is less than 55 dB. So that's the 2 cases I shared for the board piers in real commercial construction. Thank you very much.
Hello everyone, I am Anirudh Ramesh, and today I'll be talking about prefabricated piles, the kind of foundation that quietly do all the heavy lifting behind the scenes of major projects. Let me share two real projects where prefabricated piles really came to the rescue. You could say they were the superheroes of foundations. Case study 1, Barking Riverside, London. Picture this, a massive housing and commercial development built on an old power station site. The challenge, you can have a noisy, vibrating construction site right next to the existing homes. So what do? They bought in square-driven precast piles. Think of them as giant Lego blocks for grown-ups, and install them with a super quiet hydraulic hammer. No fuss, no noise, no angry neighbors. Because these piles were factory made, they were strong, consistent, and ready to use immediately. No waiting around for concrete to cure. The result, a fast, clean foundation job that kept the neighbors happy and the project on schedule. Case study 2, Axis 18, Avonmouth, Bristol. Now let's move to a big warehouse project where the floor needed to be perfectly level. They used over 1,300 precast piles, each about the size of a chunky chocolate bar, but 20 meters long, driven straight into the ground. Why choose precast here? Speed and strength. They were installing up to 25 piles a day, and the load test proved they could handle massive forces. On top of that, almost no waste soil was produced. Fewer trucks, less mess, and a smoother workflow. The result? Quick, reliable foundations with minimal environmental impact. So what's the big takeaway? Prefabricated piles are basically plug and play foundations. They go in fast, make less mess, keeps the neighbor happy, and deliver reliable, top quality results. If foundation had a superhero, this would be it. Thank you so much.